So in this video, let us start setting up our rollerball game. Let's get the ball in our scene. Let's just make a small surface for our ball to roll on. And then let's work on the script. Let's get our ball moving with the WSAD keys as well as the spacebar key to jump. Our ball, our rollerball, is going to be using physics. So it's going to be using Unity's physics system. So just to start, what I'm going to do is just kind of make a small stage so, the ball actually has something to roll on. I'm going to right click the hierarchy and add a plane. This is going to be the ground that our ball rolls on. I would just set the position to 0, 0, 0. And then just kind of scale it up. And now to make sure our ball doesn't fall, past these edges here, I'm going to just right click and add some cubes and then just kind of make them look like walls. Just to keep things sensible, I'm going to rename this cube from cube to wall. In fact, while I'm here, I'll rename plane to ground, just so we know what they are. I'm going to hit Control D to duplicate this wall, move it to the other side, and then rotate one more 90 degrees. And same thing, just kind of position it so that it blocks our ball from rolling off the stage. And finally, I'm going to right click and add a sphere. This sphere is going to represent my player. So I'm going to rename it to player. Now, if we look on this topmost bar, you can see next to the Unity version, I'm sure it's very tiny here, but you'll notice it on your own computer, is that there's a little star. And what that means is that this scene that we're working on is not saved. And so we want to save the scene. I'm just going to hit Control S anywhere, as in save. And it's going to pop up the save scene dialog. There's already a scenes folder in my assets folder, so I'm just going to save it in there. And I will call it roll ball level. The ball is currently in the ground. I don't want to be in the ground, so I'm just going to kind of move it upwards. Okay, so if I just click on my game tab, I can kind of see what my game would look like. Right now you could see that our camera is down here and it's looking kind of, very straight on at the ball. And that's kind of what this game tab shows. We will in the future kind of learn how we can just very easily add a camera follow kind of script to it. But for now, what I'm just going to do is move the camera up, back a little bit, and then just rotate it downwards. That way, we're looking at the whole level at once. Now, I mentioned that our ball is going to use physics. If I just hit play, we can see that this ball is in the scene, but it's just floating, right? It's like a static ball. And so in Unity, a physics object has a component called a rigid body. If we were doing a 2D game, there's a separate rigid body for that called rigid body 2D. And in 3D, we have a separate rigid body that's just called rigid body. So right now you can see the sphere is just kind of like up there. I'm still on play mode. I'm just going to add a rigid body component to the player. And as soon as I do that, you can see the ball falls down. I could pause the game, go back into my scene view and just move it up so we can see that again. You can see the ball's up there. When I unpause, it falls down. So this rigid body is what gives our objects physics. If I stop playing this, you'll notice that the rigid body is gone. I just need to add that again. The ground and the walls, when I made them, they just came in with these colliders. So the walls came in with a box collider. The ground came in with a mesh collider. But this is why the ball is stopping when it hits it, because it has a collider. In fact, the ball itself comes in with a sphere collider. So everything needs a collision for the physics to actually work on it. And the physics object itself, the one that's going to experience the forces and the gravity, that requires a rigid body. Okay, now let's move on and make our script for our player rollerball. So I'm going to make a new mono behavior script, call it rollball, and then just double click to open it. Once it's open, let's start. The first thing I always like to do when I start making scripts is to kind of add the variables I already know I'm going to need. So I know that because I'm going to be controlling this ball, it's going to have some kind of move speed, right? Something that we can customize, some kind of option that lets us like make it go faster, make it go slower, so that while we're testing it, while we're building the game, this option's easily there for us to, change it. And so what I'm going to do is on top, I'm going to add a serialized field. It'll be a float, and I'll call it move force. And I'll just give it a default value of something like 10. I'm also going to have a jumping ability. So, even before we start working on the jump, I'm just going to add the jump force as a variable. And then, again, set it to something like 5. I don't know if these numbers are good or bad, but that's the point of making it a serialized field. We can test them, and we don't have to keep coming back to the editor to kind of change it. Next, to actually move our object, we are going to need to use the rigid body component that is on the ball. So our ball has this rigid body component. In fact, while we're here, let me also just add this roll ball script to it. So this game object, this player game object, has every component we need to like work on it, right? It has the rigid body component and it has the roll ball script. So we just need to tell the roll ball script to use this rigid body and apply a force to it whenever we press the keyboard keys. So to do that, we need to store a reference to this component as a variable in our script. So I can make a private rigid body, because that's the name of the component, right? Rigid body, so that's the type of variable, and then give it a name. I just like to call it RB for short, like rigid body. So when we make this variable, we're telling our script that it's going to have a little spot open to store a rigid body. This just creates the variable. It does not tell it which rigid body we want to use. So we use a function for that called getComponent. What getComponent does is you tell it what kind of component you want to get. It is going to look in that game object at all the components, and it's going to give us back whichever component matches the type that we have selected. So in these angled braces, like the greater than less than symbol, we would type the component type that we want. In this case, I want a rigid body. You end it with parentheses and a semicolon. And we just set our variable equals to this. So again, what this line is saying is up here, we have created a variable of type rigid body called RB. When we make this variable, it's empty. There's nothing in it. We're just putting that as a placeholder there. It is what is known as null. It exists, but there's no value assigned to it. So when we start the game, we are telling our script to get a component of type rigid body. And what this get component is going to do, it's going to look inside its own game object, be like, do I have a component called rigid body? In our case, we do. And so it's going to return it to this value. So now our RB, once we hit start, is not going to be empty anymore. It's going to be equal to that rigid body component in our game object. If our game object didn't have a rigid body component, then this RB, this would actually return an error and it wouldn't work. Next, once we've set it, really our goal in the update, so every frame, I'm just going to write it out in comments. What we want to do is get the input. Basically, am I pressing, the W key? Am I pressing W, S, A, or D? And then if we are, add a force in that direction. So in this case, W would be in the forward direction, S would be in the backwards direction, A would be left, and D would be right. So we'll start by just getting the inputs. So Unity has changed the way it gets inputs a while back, a few years ago. They've changed the way they get inputs. If you start looking at tutorials online, they might use they might have some code that reads like input dot get axis. You can see it's kind of still here. We can't use this anymore by default. Unity has kind of changed how it works. So they've made it a slightly more robust but slightly more complicated system. The way we are going to be using it in this project is a very simple way, but it's just going to feel like it has a lot more words than just input.getKey. What we need to search for is keyboard. So there is something called a keyboard class dot current, and this represents the current keyboard, the one that we are typing on, right? The first keyboard, or whichever is the main keyboard connected to your computer. That's kind of what this represents. And then I can search for W key. And then in the W key, we're going to search for is pressed. So if keyboard.current.w key.is pressed, then I want to move forward, right? So let me just add the if there. If this key is pressed, then move forward. Similarly, if keyboard.current.s key is pressed, move backwards. If keyboard.current.a key and finally we're going to do the keyboard.current.d key is pressed. If this is pressed, we want to move right, and if the A key is pressed, we want to move left. Now, before we even, get to actually using this code to affect the ball, it's always good to use a debug.log to kind of check things, right? To see if these work. So I can have something that says W is pressed, and then I'm just going to copy these. There you go. I'm just going to copy this, and we'll change this to S. We'll change this to A. And we'll change this one to D. So now whenever we press these keys, we should just see these things logged, right? So let's go back to our Unity. The rollerball script is attached, and so we should see those values print out. I'm going to go to the console. If I press W, you can see W is pressed, and we can also see that number is going up as I'm holding W. I'm still holding it, and now I'm going to let it go, and it stops printing. Same thing with S, same thing with A, same thing with D. And so what this does is by printing it, now it informs us about the behavior of this, command that we've just called, this function we've used, the w.key.isPressed. It informs us about that. It tells us that when we are pressing W, for every frame that it's held down, it's going to call true. It's not just the frame that we click it, but for every frame we hold it, it's going to be true. For every frame it's not held, it's going to be false. Okay, so what we are going to do is we are going to use something called add force, which is a function on the rigid body. So if I searched RB, which is the variable for our rigid body, you can see that there is an autocomplete that says add force. And add force takes a vector 3. That's a force. That's the name of the variable, but it takes a vector 3. That's the important part. So we're going to add a force. And that force, the force that we add, is going to be informed by this, the button that we press. So I'm going to delete these comments. I'm going to make a variable for that. So I'm going to make a vector3. I'll call it movement, and I'll just set it initially to vector 3.0. And vector 3.0 is just a shorthand of saying 0, 0, 0, just like a zero vector. So if W is pressed on that frame, then I want to take my movement and I want to add to it vector 3.forward. If we're going backwards, I want to add vector 3.back. If we're going left, I want to add vector 3.left. And finally, if we are going right, I want to add vector 3.right. And so just to kind of clear up what does forward, back, left, and right mean, if I was to real quick go back to the engine, where it's going to give me some errors now just because we didn't write the code properly. If I click on this, we can see that these arrows here, right? This represents the z-axis, this represents the x, and this represents the y. In game engines, we also refer to these axes by directions. So specifically in Unity, we call the z-axis the forward axis. So when we go positive on the z-axis, that's going forward. Negative on the z-axis is either minus forward or, in this case, backwards. Same thing. The x-axis is called the right axis. So if we're going positive on the x, that's right. Negative on the x, that's left. And then same for the y, that's up and down, right? So positive on the y is up, negative on the y is down. So in our code, when I'm talking about vector 3 left, back, forward, right, that's what it's saying. Forward is just 1 on the z-axis, back is -1 on the z-axis. These are shorthand ways of writing that. So I want to add a force that's going to be the movement multiplied by our move force. The last little thing I want to do just before we go test it, instead of just using movement, I'm also going to normalize it. So I'm going to call movement.normalized. All normalized means is if this forward for some reason was beyond the value of 1, it's just going to bring it down to the value of 1. Normalizing just means taking whatever vector we have and just bringing it down so it's a scale between 0 and 1. And this is good for us because we're multiplying it with a move force anyway, right? So it doesn't really matter. So now we can test it. But before we do, let's just think about what we did. So on every update, we just zero out this movement vector. So in the beginning of the frame, it's 0. Depending on the keys that we pressed, we are going to add a value into movement. So if we press multiple keys, for example, if we press W and A, we're going to add forward and left into that movement vector. And then we're just going to add a force at the end of our update. We're just going to add that force onto our ball. Let's go back and check that out. And really the other thing I just want to do before I test it out is in our rigid body right now, if I open this little constraints panel, you can see that there's freeze, position, and rotation. I know technically we call this game roll a ball, but the ball isn't or shouldn't really be rolling. Like we don't want it to roll around. So I'm just going to freeze these. Really, I should have called it slide a ball, but roll a ball just makes more sense, right? We don't want to freeze the positions because we want the rigid body to move, but we don't want it to rotate. And so now I can hit play, and with my WSAD, I can move around. I think it's a little too fast right now. And there's a couple things I could do with that. I could change the move force. So if I turn the move force down to 5, for example, and I'm doing all this with play on, by the way, now it feels a little slower. Or I could adjust the rigid body settings themselves. I could turn up the mass. So if I turn the mass to 5, right now you can see it's barely moving. If I turn this back up to 10, it's moving, but it feels a lot weightier. It takes a lot more time to accelerate. I could also maybe turn up the force, maybe something less than 50, like 25, and then turn up the dampening, maybe give the dampening 5. And now same thing, it feels a lot more sticky. There's a lot more friction. It's coming to stop a lot more easily. And so like that, we can change these values and we can kind of adjust how our ball feels based on your preference. Again, that's I think the best way to do it is to like hit play, play the game, be messing around with it, change the values, and then when you're done, just remember the values that you have here, and then stop the game and write them. So in my case, it's 5, 5, and then I change the move force to 25. I'm going to stop the game and change it to that. And so that's what I mean by like when we write the code, we can't like just imagine what the value should be. It's great when we make it a serialized field and we can change it while playing the game. It's a very like convenient thing that Unity has for us. Okay, next, let's add the jumping feature. So in my case, if we hit the spacebar key, I want to jump. So I will say if, again, keyboard dot current dot space key is pressed. But here's the thing, with the is pressed, if we remember, the way is pressed worked was every frame that we press the key, we are going to jump. Or I'm sorry, every frame we have the space key pressed, it's going to return true, right? So what that means, what's going to happen, if I was to use is pressed, is if my player holds down spacebar, they jump up, they land on the ground, they're still holding spacebar, they're just going to jump again because that is pressed is true, right? I don't want that. What I want is for them to let go of the spacebar key and hit it again. So instead of using is pressed, we can search for a different value in here called was pressed this frame. So this only returns true the frame that it was pressed. That one frame it was pressed, it's going to return true. Again, we can just see this in action before we use it. So I'll debug.log spacebar is pressed. And so now I'm going to run this game. And I'm going to press the spacebar key and hold it. And you can see it only prints out the one time. I let it go and I press it again, it prints out again. So every time I press it, it's going to register once, which for a jump key, I think that makes more sense to work like that. So same thing, in this case, I want to add a force. I want it to be an upwards force, so I'm just going to use vector3.up. We're going to multiply this by the jump force. And I'm going to use a comma, and there's another option. Like again, if we look at this tooltip, it says vector3 force, and then it asks us for a force mode. And I want to use force mode dot impulse because this is going to be like a one-time impulse. If I just hover over the impulse thing, we see a tooltip pops up and it says add an instant force impulse to the rigid body, which is what a jump is, right? We wanted to just like add that impulse so it flies upwards and then kind of comes downwards. It's not a gradual force. It's not like how we're walking or running. It's not a gradual force. It's a burst of force. So we want to use the force mode impulse. All right, let's give this a shot. I hit the spacebar key. Maybe my impulse was a little too small, so let's change it up to 10. Still a little too small. Let's make it 25. Still a little small. Make it 50. There you go. I think that makes more sense. So you can see I go up and I come down pretty slowly. And I think that's because of my linear dampening. If I turn that off, you can see it's a little bit more normal per se. So this works, right? I can move around, I can jump. The only problem right now is we're not really telling it that we can only jump when we're on the ground. That is the case. I do only want to jump when I'm on the ground, but I'm not telling it that. So if I just spam the space bar, the ball goes flying up somewhere. So okay, that's going to be our next step. What I want to tell the engine, or what I want in my script, is that only when the ball is grounded should we also jump. So really, I want to have a new Boolean. So I'll call it bool is grounded, and it's going to start off we won't give it a default value. And what we want to check is if our current frame, if spacebar was pressed, and so using these two ampersands, and if is grounded is true. We could type is grounded equals true, but because is grounded is already a Boolean, we could just do is grounded, because what's going to happen is this is grounded, like when we're running the code, is going to be replaced with the value of is grounded, so it'll be true or false, right? And so if this keyboard key was pressed and if we're grounded, then we should jump. As soon as we jump, well, we're not going to be grounded anymore, right? So we want to set is grounded to false as soon as we jump. When do we want to set is grounded to true? Really, when we touch the ground again, right? And so for that, the way I'm going to do it is by checking if my sphere collider, which is what this player has just touched another collider. So as soon as we touch another collider, we should be able to jump again. When we're in the air, we're not touching anything, right? And we come down, we touch another collider, we know we're touching the ground again, so we should be able to jump again. So to check for a collision, we use a special function. So it's not update, but we use a special function called void on collision enter. Let's just read this tooltip here. On collision enter is called when this collider or rigid body has begun touching another collider. So when our collider touches another collider, our on collision enter is going to run. And so when this function runs, we know is grounded is true again. And let's go check it out real quick. I'm going to hit play. I forgot to change my thing, so I'm just going to make my jump force 50. I hit space, come down, hit space again. I can still jump, but I'm going to spam space. And you'll see that I only jump when I touch the ground. However, say I had this wall here, and let me just scale it up. If I was to jump, hit the wall, and jump again, you can see it lets me jump one more time. Every time I touch the wall, it just lets me jump again. This is an ideal behavior, right? I only wanted to jump when I touched the ground. And so I want to actually be able to differentiate between two different colliders. I want to be able to differentiate between the ground and the wall. And to do this, we can use a concept called tagging. Tagging is kind of us putting different game objects into different categories. If I click on this game object, any game object really, but with the ground selected, you can see under its name, there is something that says tag untagged. If I drop this tag down, you can see there's a bunch of like kind of default ones Unity has: respawn, finish, editor only, main camera, player, game controller. And actually, if I click on the main camera, you can see its tag is already main camera. So it's like Unity kind of like gives it that tag by default. So I want to make my own tag for all our ground objects so we can differentiate between ground and wall. And in fact, later on, if I wanted to add a wall jump, I could do it like that, right? We could have a wall separate that gives us a different kind of jump because we need to jump away from the wall and not straight up. So I'm going to hit this add tag button that takes us to this inspector called, this inspector kind of place called tags and layers. There is tags right here. It says list is empty. All the way to the right on the bottom, I hit the plus key. and I can add a new tag. I'm going to call this tag ground. It's very important we remember how we name these tags. So in my case, I always start my tags off with a capital letter, because when we look for tags, we need to type out the name exactly the same. If I use a lowercase ground, I should remember that. So in my case, I always use an uppercase to start it. So you can see here it says tag 0 ground. I can go back to my ground, drop down tag, and then give it the tag ground. Save that, and then let's go back to our script, where I don't want to just check if I'm grounded. I want to check if, and we can see here this void on collision enter. It takes a parameter called of type collision called collision. And what this parameter is when this function runs, and remember, on collision enter runs when one collider collides with another collider. This collision is set to that other collider. It's a reference to whatever we collided with. So when I collide with the ground, this will be set to the, this will give me a reference to that ground game object. And so I can check if the collision, which is the name of that variable, dot game object. So the collision is the collider itself. I'm checking the collider's game object. And we can use a function called compare tag, where we're just checking, does it have the tag? And in my case, does it have the tag ground? If it does, and only if it does, will I set is grounded to true. So again, let's increase the size of this wall. Keep the ground as ground. I need to change my jump force. Let's make it 50. And we can see that if I jump, all good. I can jump again. I can't jump in the air. And if I touch this wall, I can't jump anymore. And so there you go. Very simply, we have created a very simple script. It's a very simple script, very simple player controller that uses the rigid body, and we can move our we can move the ball around using forces. We can use this keyboard event to check if we've jumped, and then add the jump, like jump straight up. And then we also check when we're touching the ground. We know how to differentiate now between two colliders using this tag. We can use that in many different ways. But this is just the basics, very simple script. And in the next video, we will learn how to just attach a simple camera to it so that we can kind of like have a larger level. We'll also add a simple like camera controller to it so that we can actually move the camera with our mouse. This is all very simple. We won't even have to code anything. Unity kind of gives us this functionality, which just kind of helps us prototype this game quicker, right? Rather than like making a camera script, we're able to have our ball rolling around and build like a large obstacle course for it that way. Anyway, thank you guys for watching.